Hello everyone. Today we're going to learn how to switch between the different forms of quadratic equations. Write the following equations in standard form. Standard form is y equals ax squared plus bx plus c. Example 1 has the equation f of x equals 2 times x minus 1 squared plus 3. This equation is currently in vertex form. To go from vertex form to standard form, we need to multiply everything out and combine like terms. So we're going to multiply and then simplify. My first step when doing this is going to be to multiply x minus 1 squared. Remember that x minus 1 squared is the same thing as saying x minus 1 times x minus 1. To multiply a binomial by a binomial, I use the area model. I'm going to take one binomial and write it down the side, and I'm going to take the other binomial and I'm going to write it across the top. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. And negative 1 times negative 1 is positive 1. So inside of the area model, I have x squared minus 1x minus 1x plus 1. To simplify this, I'm going to combine my like terms and get x squared minus 2x plus 1. So what we have just done is we've multiplied x minus 1 squared. And when we did that, we got x squared minus 2x plus 1. So I'm just going to go ahead and replace x minus 1 squared in this equation with x squared minus 2x plus 1. And when I do that, I'll have f of x equals 2 times, and now we have x squared minus 2x plus 1 from the area model, plus 3. Again, the 2 came from the coefficient out in front, and the 3 is a constant on the end. Step 2 is to distribute. So now I can go ahead and distribute this 2 to everything inside the parentheses. And so I'll have f of x equals 2x squared minus 4x plus 2. And then I'm going to bring down my plus 3. My final step is to combine like terms. 2 and 3 are like terms. So I'll have f of x equals 2x squared minus 4x plus 5. This equation is now in standard form. So let's talk about these two equations real quick. The original equation that they gave us, f of x equals 2 times x minus 1 squared plus 3, is equivalent to the equation that we just found, f of x equals 2x squared minus 4x plus 5. These equations will create the same quadratic graph. So if you were to graph both of these, they would give you the same parabola. So it's the same quadratic function, just in different forms. Let's look at example 2. On example 2, we have y equals x minus 4 times x plus 10. This equation is currently in factored form. Factored form is the same thing as intercept form. And so to go from factored form to standard form, I just need to multiply these two binomials together. To multiply these two binomials together, I am going to use the area model. I'm going to take one binomial and write it down the side, and I'm going to take the other binomial and write it across the top. X times x is x squared. X times 10 is 10x. Negative 4 times x is negative 4x. And negative 4 times 10 is negative 40. So that's step 1. So currently my equation is y equals x squared plus 10x minus 4x minus 40. My next step is to combine like terms. Well, x squared doesn't have a like term, so I'm going to bring that one down. 10x minus 4x is 6x. Oops. And then negative 40 doesn't have a like term, so I'm going to bring that one down. So my equation is y equals x squared plus 6x minus 40. This equation is now in standard form. For the next two examples, they want us to write the following equations in vertex form. Vertex form is y equals a times x minus h squared plus k. On example 3, I have g of x equals x squared plus 2x plus 4. This equation is currently in standard form. To go from standard form to vertex form, we are going to complete the square. So I'm going to take my x's and I'm going to put them inside the parentheses. And then I'm going to take my constant of 4 and I'm going to write it on the outside of the parentheses. When I find the number that completes the square, I'm going to add it to the inside of my parentheses. But because I have an equation, I can't just add a random number to it. So to keep the equation balanced, if I add a number on the inside of the parentheses, I am going to have to subtract that number on the outside of the parentheses. Let's think about that for a second. If you add a number inside and then subtract the number outside, you're essentially not changing the equation because it's like you're adding 0. So you're just writing an equivalent form of the equation. Because let's say if I add 3 here, oops, there we go. If I add 3 here and then subtract 3 here, 3 minus 3 is 0. So you're essentially adding 0 to the equation, and if you're adding 0, it's not changing anything. So let's find the number that completes the square. The method that I like to use to do this is by drawing an actual square. I think it's a great visual representation of what we're trying to do. So to complete the square this way, you write your first term in the first box. Now I want the shape right here to be a square and not a rectangle. The difference between a square and a rectangle is that in a square, all of the sides are the same length. To make it so that this side is the same as this side, what I'm going to do is I'm going to split my middle term in half. So if I divide 2x by 2, that gives me 2x. Or sorry, not 2x, 1x. There we go. Because 2x divided by 2 is 1x. So now you can see that this side length will be the same as this side length, making this shape a square and not a rectangle. The greatest common factor of my top row is x. The greatest common factor of my left column is x. X times 1 would give me a 1x in this top box, and x times 1 would give me a 1x in this bottom box. And now we can literally complete the square by finding the number that goes here, and that will complete the shape of a square. To find the number that completes the square, we just need to do 1 times 1. 1 times 1 is 1. So 1 is the number that completes the square. So it's going to be the number that I add to the inside of my parentheses and I subtract on the outside of the parentheses. We have just factored x squared plus 2x plus 1. And when we factored it, we got x plus 1 times x plus 1. X plus 1 times x plus 1 can also be written as x plus 1 squared. And so now I have g of x equals x plus 1 squared. The only thing I have left to do is 4 minus 1. 4 minus 1 is 3. This is the equation written in vertex form. Let's see what that process looks like with example 4. On example 4, we have y equals x times x plus 4. This equation is currently in factored form. I know that because I can see clearly the two factors. To go from factored form to vertex form, we're going to need to distribute and then complete the square. By distributing, we're first going to get this equation in standard form, and then from standard form, we will complete the square, which will get it in vertex form. So my first step is going to be to distribute. X times x is x squared. X times 4 is 4x. This equation is currently in standard form. So now I'm going to do the same exact steps that we just did on example 3. I'm going to put my x's inside parentheses. Now I don't have an extra constant here to add to the outside over here. So it's just going to stay blank for now. When I find the number that completes the square, I'm going to add it to my inside of my parentheses, and I'm going to subtract it on the outside of the parentheses. Now I'm ready for the process of completing the square. Here's my square. First term goes in the first box. I'm going to divide my middle term by 2. That way I make a square and not a rectangle. 4x divided by 2 is 2x. The greatest common factor between x squared and 2x is x. The greatest common factor between x squared and 2x is x. x times 2 is 2x, and x times 2 is 2x. So the number that completes the square is 2 times 2, which is 4. So 4 is the number that completes the square. That is the number that I'm going to add to the inside of my parentheses and subtract on the outside of my parentheses. We have just factored x squared plus 4x plus 4. The factors are x plus 2 times x plus 2. X plus 2 times x plus 2 can also be written as x plus 2 squared. And then I'm going to bring down my minus 4. This is the equation in vertex form. On the next two examples, it says write the following equations in factored form. Remember, factored form is also known as intercept form. And that equation is y equals a times x minus p times x minus q. For example 5, I have h of x equals 2x squared minus 5x minus 3. This equation is currently in standard form. To go from standard form to factored form, I need to factor. Your first step with factoring is to always look for greatest common factor. Here I do not have one. So now you can use whatever factoring method you like. I prefer the area model. To use the area model for factoring, you put your first term in your first box and your last term in your last box. You always need to multiply your first number by your last number. 2 times negative 3 is negative 6. So I'm looking for factors of negative 6 that add to my middle term of negative 5. Those two numbers are negative 6 and positive 1. Those are going to be the numbers that go in the empty spaces of my area model. The greatest common factor between 2x squared and negative 6x is 2x. The greatest common factor between 1x and negative 3 is 1. The greatest common factor between 2x squared and 1x is x. And the greatest common factor between negative 6x and negative 3 is negative 3. So now my equation is h of x equals 2x plus 1 times x minus 3. This is now in factored form. On example 6, I have y equals x minus 4 squared minus 36. This equation is currently in vertex form. To go from vertex form to factored form, I need to get it in standard form first. And then once it's in standard form, we can do the same exact steps that we just did on example 5 to get it in intercept form. Steps 1 and 2 are the steps to get it in standard form. So you want to go to standard form first. And then once you're in standard form, you're going to factor to get it into factored form. So my first step to get this equation in standard form is to multiply x minus 4 squared. This is just like what we did on example 1. X minus 4 squared really means x minus 4 times x minus 4. To multiply a binomial by a binomial, I use the area model. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is 16. Step 1. So now my equation is y equals x squared minus 4x plus 16. And then I got to bring down my minus 36. Step 2 is to combine like terms. So x squared doesn't have a like term, so I'm going to bring that down. Negative 4x minus 4x is negative 8x. And 16 minus 36 is negative 20. Y equals x squared minus 8x minus 20 is in standard form. To go from standard form to factored form, we need to factor. Your first step with factoring is to always look for a greatest common factor. Here, I do not have one. When you do not have a greatest common factor, I go straight to the area model. That is just my method of choice. So my first term goes in my first box, and the last term goes in the last box. My first term, or my first number, times my last number, 1 times negative 20 is negative 20. So I'm looking for factors of negative 20 that add to my middle term of negative 8. Those two numbers are, there we go, negative 10 and positive 2. Those are going to be the numbers that go in the empty spaces of my area model. The greatest common factor between x squared and negative 10x is x. The greatest common factor between 2x and negative 20 is 2. The greatest common factor between x squared and 2x is x. And the greatest common factor between negative 10x and negative 20 is negative 10. So my equation is y equals x plus 2 times x minus 10. This equation is now in factored form. Down here at the bottom of the page, I've summarized all the different steps for going between all the different methods. So everything that we've done on examples 1 through 6. So to go from standard form to factored form, you factor. To go from standard form to vertex form, you need to complete the square. To go from factored form to standard form, you multiply. To go from factored form to vertex form, you multiply and then complete the square. To go from vertex form to standard form, you multiply and then simplify. And from vertex form to factored form, you multiply, simplify, and then factor.